Guess what? ReuseLogic Nexus is completed, and this is the very first video of a series where I show you how to properly use it in actual projects. A minimal knowledge of the observer pattern and state machines is required. Leave a comment if you want me to cover them in the future videos. As a side note, at the time of publishing this video, the add-on is not yet submitted to Godot Asset Lib because I'm writing a comprehensive documentation for it. This is why you subscribe and hit the bell right now to get notified when the add-on is accepted on Godot Asset Lib. What is ReuseLogic Nexus? ReuseLogic Nexus, based on singleton pattern, observer pattern, mediator pattern, and signal-driven state machines, provides you with a workflow which will make your life much easier as a game developer. Let's get started by making a practical example. Starting with a new project, let's make the add-ons folder and add the add-on to it. Enable the add-on in the project settings and reload the project just to make sure nothing stupid happens. Making an example folder, add a simple node 3D for the level. The static body 3D containing a collision shape 3D and a mesh instance 3D is the ground the player walks on. To make it look better, I use a noise texture so I can feel the movement speed. Now it's time to add the player. Make a new scene with character body 3D as its root node. Add collision shape 3D and mesh instance 3D with a capsule shape. Move it up so it stays on the ground. Adding the player to the level. Let's put the sun in the scene to see the player shadow. Now add the camera 3D to the player and everything is ready to get started. Fortunately, Godot comes with a ready-to-use script template for character body 3D. Attach the script and run the game. As you see, you can't move because we need input map actions. Let's add left, right, up, down, space, and WASD. I'm gonna use the left, right, up, and down to get the direction of the movement, and I'm gonna use the WASD for the state machine. More on that later. Now we need to make the code use the new actions. Running the game, everything seems to be working perfectly. I don't like the speed though, so let's fix the variables and export them to the inspector. Time to add the state machine, but before that we need to completely understand what our states are, what they do, and how they are connected to each other. ReuseLogic Nexus state machine is signal driven. This means that it doesn't contain any actual logic. The states only hold the information of signal connections. This means that they only listen to specific signals and only emit specific signals in return. All the signal connections are specified in the inspector. That is why you don't need to write a single line of code to use them, and they are reusable. For now, I want the player to have 3 states: idle, walk, and jump. Each state starts on some specific signal. This means that we need 3 signals: idle start, walk start, and jump start. We also need a signal for each input action, so we need space, WSD, and WSD release. We don't need dedicated signals for left, right, up, and down input actions, because in this simple example, we just need to know if any of them is pressed. It doesn't make a difference which one is causing the movement. We also need walk and jump signals to make the player do what it's supposed to do. And we also need the is on floor signal to inform the system when to switch from jump state to idle state. The idle state starts on idle start signal and it emits walk start and jump start signals if WASD and space signals are emitted. The emitting of walk start and jump start will cause the state manager to switch to walk and jump states, because these are the signals the walk and the jump states are listening to. The walk state listens to WSD and emits the walk signal in return. This is the signal to which the player walking functionality is connected. On WASD release, the idle start will be emitted, so the system switches back to the idle state. Of course, the player can jump while walking. This is why the walk state listens to a space signal and emits jump start in return. The jump state emits the jump signal at the beginning and listens to is on floor signal to switch back to the idle state. Now that we know our states, it's time to actually implement them. ReuseLogic Nexus comes with a super handy module called the brain. It acts as a state manager and contains all the valid signals of the whole system. This means that you are not supposed to implement any signal outside the brain inspector. Let's add the signals we discussed earlier. Now it's time to add the states. Again, ReuseLogic Nexus comes with another super handy module called the brain state. Let's add 3 of them and name them appropriately. The signals added to the brain inspector are available in special properties called signal pickers. This enables us to easily set up the signal connections in our state inspectors. Let's do that. The input signals are never emitted. Input Manager is another handy module of ReuseLogic Nexus. Let's add it and set it up. The input actions are checked in the physics process of the character controller script, so we need to emit the appropriate signals in the physics process array of action emitters. The first field contains the name of the action and the drop-down contains the list of the valid signals specified in the brain inspector. Adding a space action and the space signal in the physics process just press list means that the space signal must be emitted if the space action occurs in the physics process function, and the check input dot is action just press is gonna be used for it. Let's choose idle state as the initial state of the brain and turn on debug so we can see if the states are working as expected. Running the game, you notice that the jump state never switches back to the idle state. The reason is that we don't emit the is on floor signal. Adding an export group for the signals, I'm gonna use the special property signal picker child to get access to the brain signal list. The child version of the signal pickers scans the node hierarchy down to catch the first brain in the system and populates its drop-down list based on that. We also need a reference to the brain itself, and we also need to emit the signal picked in the inspector. I'm passing an empty dictionary for the data. We'll discuss data sharing in a future video. For now, keep it in mind that any function connected to brain signals must accept one parameter of type dictionary. Running the game, you see that the states are working as expected. Now it's time to connect the actual player logic to the states. We need two signal pickers and two functions, walk and jump. Connecting the functions to the signals in the ready function, run the game. It is indeed working. Let's move the actual logic to the appropriate functions. There are two problems. The player doesn't stop when the idle state starts, and the jump state switches back to the idle state immediately after it is initiated. Let's solve the walking problem first, making a velocity reset function connected to a new signal. We need to emit the new signal when the idle state is initiated. And the walking problem is solved. To solve the jumping problem, we need to separate the jumping process into two states, jump and fall. Let's add its falling and fall star signals to the brain. We need to detect if the player is falling in the character controller script and emit the is falling signal if that's the case. So let's add a new signal picker child to the script and do the check in physics process. Now the jump state needs to switch to the fall state if its falling is emitted, and the fall state needs to switch to the idle state when the is on floor signal is emitted. It is not working because I forgot to make the fall state start on the emitting of the fall star signal. Run again and everything is working as expected. Now let's add the mouse lock system to the game. Adding mouse sensitivity variable to the script, let's put the logic in the unhandled input function. Pause the video and read the code if necessary. We should also set the mouse mode to captured so it works as expected. I had an indentation problem in the code. Run again and it's working perfectly. There is a problem though. The idle and walk states don't switch to the fall state. Simply make them listen to its falling signal and emit fall star signal in return. Okay, this video is already getting lengthy. In the next parts of the series, I'll expand the character controller by adding more states, and I'll also cover other handy modules of ReuseLogic Nexus Addon. Subscribe and hit the bell, because I'm about to revolutionize your game development workflow.